The James Webb Telescope. How it could reveal some of the universe's best-kept secrets. Keep an eye on things and we'll show you. Martin Barstow, professor of astrophysics and space science at the University of Leicester. If everything goes as planned, we will soon enter a new era of astronomy. The James Webb Space Telescope, or JWST, the largest, most expensive, and most complex space telescope ever built, is now in orbit, on its way to its final destination. Hello and welcome to another fantastic video from our Space Trek channel. We'll show you and tell you about the James Webb Telescope's terrifying discovery at the edge of the universe in this video. But first, please subscribe to our channel and press the bell button so you don't miss any of our videos. So let's get this party started. The launch of the $10 billion James Webb Space Telescope on Christmas Day 2021, which had been anticipated for over a decade, was both exciting and terrifying for the thousands of scientists, engineers, managers, and support staff who had brought the mission to this point. As chair of the Space Telescope Scientists Institute Council, which will run the JWST Operations Center, I understand their concerns. After all, the JWST has enormous scientific potential and could answer some of the universe's most pressing questions. The mysterious early universe. JWST is frequently billed as a replacement for the Hubble Space Telescope, but I prefer to think of it as a successor. Hubble has now been in operation for more than 30 years, providing us with breathtaking views of the universe as well as thousands of scientific discoveries. We hope and anticipate that it'll continue to operate for many years to come. However, the relatively small 2.4-meter diameter mirror, when compared to ground-based telescopes, limits its sensitivity and ability to observe the faintest objects. Furthermore, while Hubble can observe in infrared light, it cannot access the wavelengths of light from the very first stars and galaxies. However, the JWST will be able to do so. It may even be able to see population 3 stars, stars formed from primordial material from the Big Bang that have never been seen before. Knowing when the first stars formed shortly after the Big Bang and how they produced the building blocks of the first galaxies is an important scientific question and one of the primary science goals of JWST. We know that elements needed for life in modern technology such as carbon, silicon, and gold were created in early stars, but we don't know how. The need to detect faint objects in the distant universe drove the design of the observatory, determining its size, wavelength coverage, and the need to keep it very cool to minimize unwanted background light. JWST will study not only the first stars and galaxies. It is envisioned as a general-purpose observatory to which astronomers from around the world can apply from time to support their research. Observing in the infrared, for example, will allow JWST to see through the clouds of dust that encircle very young stars, which are opaque to visible light. Unlike Hubble, it'll be able to peer directly into stellar nurseries, where stars and their planetary systems are formed. The observations will provide answers to questions about how clouds of dust and gas collapse to form stars and how planetary systems form around them. Habitability of exoplanets. When the first JWST plans were discussed more than 20 years ago, no planets other than those in our own solar system were known. Since then, astronomers have discovered thousands of planets orbiting other stars in our galaxy, exoplanets. A significant portion of the JWST observing program will be devoted to studying their atmospheres. JWST's wavelength coverage is particularly well-suited to studying molecules in exoplanet atmospheres and the low infrared background from space, giving it a significant advantage over Earth-based telescopes. There are two techniques available. One takes advantage of the fact that planets can pass in front of their parent star called a transit, causing a dip in the light we see from it. We can probe the planet's atmosphere by analyzing the light, broken down by wavelength with great precision before enduring a transit. Another method employs a special instrument known as a chronograph to block the light from the parent star, allowing direct imaging of the planet and study of its atmosphere or surface. This could help determine whether a planet is suitable for life, possibly warranting further investigation, and one day sending mini space probes there. The ultimate goal is to find a planet similar to Earth, but this would require a very lucky combination of circumstances because they're likely to be rare in the solar neighborhood and very faint compared to the parent star. JWST will most likely study gas giants such as Jupiter and Saturn, as well as ice giants such as Uranus and Neptune in our own solar system. None of the known planetary systems resemble our own, with many giant planets in closer orbits, more extreme heating of their atmospheres, and more dynamic weather conditions. In addition to studying planets outside of our solar system, JWST will be able to observe our own solar system. Its high sensitivity will allow it to detect and characterize comets and other icy bodies in the solar system's outermost regions. In such a remote location, these objects have remained largely unchanged since their formation, and may hold clues to Earth's origins, particularly the source of its water, which may be the result of bombardment by such bodies early in its lifetime. JWST will also be able to study the atmospheres and seasonal weather variations of all planets that orbit the Sun outside of Earth's orbit. Detailed plans and ideas for what will be discovered are required to justify the expense of building an ambitious, game-changing telescope like JWST. However, there will be surprises that no one can predict. Exoplanets were largely science fiction when Hubble was launched, but studying them became one of its major tasks. I'm curious about what surprises JWST will bring us. And that's all we have for now. Thank you for watching. If you enjoyed this video, please like, share, and subscribe to our channel for more fun and informative videos. Until the next video.